Hello everyone, I welcome you to this online course on remote sensing for natural hazard studies. This course is supported by NPTEL. My name is Dr. Rishikesh Bharti and I am the course instructor of this course. I am a faculty member of the Department of Civil Engineering, IIT Guwahati. For more details about me, you can refer to my webpage. I hope you have visited the course webpage on the NPTEL website. The webpage contains full detail about the syllabus and the mode of assessment or the assignments. So let me briefly introduce you to this particular course. This course will introduce the participants of this course to the state-of-the-art concepts and practices of the geospatial techniques used for natural hazard studies. It starts with the fundamentals of remote sensing and GIS, and subsequently its application in natural hazard studies will be covered. This course is designed to give a comprehensive understanding of the application of the remote sensing and GIS in natural hazard studies, and it is expected that upon completion you will be able to use remote sensing and GIS in your hazard studies. As this course does not have any prerequisite, students of any level can take this course. This course can be taken by BTech, MS, MSR, MSc, MTech and PhD students as well as by the working professionals. The syllabus has been designed to bring different levels of a student to a single platform before the application of remote sensing in natural hazard studies is discussed. Because many of you might be having the remote sensing background, many of you may not have any introduction even to the remote sensing. So for such problems, I thought of designing this particular course in such a way that everybody should know what is remote sensing and how it has been utilized in different hazard studies. So this is a 12-week course with 10 modules, and here you can see all these 10 modules are listed. So the first module, it starts with basics of remote sensing. Then I will be covering the concepts of remote sensing, then data processing, potential of remote sensing in hazard studies, flood studies, cryosphere, avalanche and glacial lake hazards, landslides, liquefaction and drought. So all these modules have been divided into different lectures, right? So here you can see this is week 1, 2, 3, 4, 5, 6 are here, 7, 8 are here, 9, 10, 11 and 12. So there are 12 weeks with 10 modules, right? Each module will have an assignment for better understanding of the concept. In my experience, when you have an assignment, you will quickly learn the topic, right? That is why assignment has been put into this particular course. Information related to the assignments will be available in your NPTEL login. You may ask your doubts, if any, through your login. So once you register to this particular course, then you will have a forum where you can ask the question, and that will be visible to all the students, and the reply by me that will be also seen by the others, so that if they have the similar doubt, it will get cleared. In addition to this, few live sessions will be there that will help you to clarify your doubts. And here you can see the lecture assignments. So here for module 1 you have 3 lectures, then 1 assignment. Similarly for module 2 you have 3 lectures, 1 assignment. For third module you have again 3 lectures and assignment. Similarly for all these you have assignment at the end of that particular concept, right? So let me briefly introduce you to this particular course. As you know, this course is about the application potential of remote sensing in hazard studies. So this course has 2 important aspects, right? The first one is remote sensing and the other one is the natural hazard. The basics of remote sensing will be covered in this course, which is required to understand its application potential, because unless until you don't understand the remote sensing basics, you will not be able to perceive how you will be able to utilize it in your study. Then all these hazards will be covered: flood, cryosphere, avalanche, glacial lake hazard, landslide, liquefaction, drought and so on will be covered in this particular course. During this course, a few case studies will also be referred to explain the potential of remote sensing in hazard studies, so that we will be going through during the course. So, with changing climatic condition and increased anthropogenic activities, natural disasters are very frequent. You might have heard various types of disaster which is happening around you, right? And it is because of the increased human activities, anthropogenic activities and the changing climatic condition, right? So, here you have the example of avalanche, then flood, drought, landslides and other cryospheric hazards, right? This course will introduce the geospatial technique as an important tool in studying natural hazards, because sometimes what happen, the field investigation or the in situ measurement. So, many times what happen, field investigation and in situ measurements are very difficult in some of the weather condition as well as some of the topography as well as some of the location, right. So, in such situation, geospatial technique is one of the powerful tool that will provide you the input that is required to model your hazard, right. This is the example of landslide. Here you can see, if you have experienced it or if you have seen it in the field, you might be knowing that how devastating it could be. So, landslides are downward and outward movement of slow forming materials composed of natural rocks, soil, artificial fills or combination of these materials, right. So, here if it comes to this particular location, this whole road is blocked in this case, and which is hindering the transportation of this area. This is the example of flood. Here you can see how people are struggling to survive in this, right. Then comes the cryospheric hazard. So, here the list is long. Here you can see sea level rise, and according to this report which is from NASA, so this sea level is rising and it has reached to this 100 millimeter since 1995, right. So, it is continuously rising. So, that means the glaciers or the snow that is melting. Then comes the glacial surges, because of the more melting, changing in the climatic condition, that will affect the downstream area. Rock, snow or ice avalanche, here this is one of the very critical condition. If you have heard or if you follow the news channel, this avalanche is one of the major problem in the high altitude region which is glaciated or which is having the snow. Seasonal floods due to snow melt. So, here you can see more water will come and our rivers are having a specific geomorphic threshold which can accommodate a limited amount of water, but due to excess melting, what happens, there will be flooding in the downstream, right. Glacial lake outburst flood, which is nowadays very common. The glacial lake formed at the snout of the glacier, they are getting breached because of many parameters, and that is again causing the devastating scenario in the downstream. Debris flow, this is another problem where the debris which is coming on the path of this water, everything will be carried and this will have more momentum and the velocity that will cause more disaster. Then comes the mass wasting due to permafrost degradation, because when we are talking about the continuous melting or more melting of the snow or glacier, what is happening? There is a mass wasting. Because of that, these areas are destabilized, right? Then snow glacier melt, which is very obvious. I will show you one example where remote sensing images have been used, and here you can see these videos. So, here this is for the accumulation period, this is from Sikkim, and here you can see during the ablation. Ablation is the melting time, accumulation is the deposition time, right. So, this is from Tista watershed, and here you can see how it is changing, the spatial distribution is changing, right. So, that is actually very evident from the remotely sensed images. So, the remote sensing images can be used to study the spatial distribution of the snow or glacier present in an area, right. In another example where we have studied the glacial lake vulnerability, right, how a glacial lake is vulnerable. So, here you can see using the AHP based vulnerability assessment. So, the AHP based vulnerability assessment gives you an image or the output which is having different color, right, and these color can be used to read this map, or some of the lakes are with red color, that is high vulnerable lake, green colors are moderate, blue is safe, and the outside this is the Sikkim boundary, right. So, here you can see that all these areas are having different lakes and they are having different vulnerability, right. So, one of the lake which is here you can just see, so which we have also visited and we found it is in the moderate level, right, moderate vulnerability, and in the field during the summer this was the situation. So, this kind of analysis can be performed. In another example from the South Lona Glacial Lake, it has witnessed with substantial increase in lake area, that is 13.67 times, thereby lake volume since 1967. So, here you see in the 1967 with the help of corona satellite image, we found that this is the shape of this particular glacial lake, right. So, this is South Lona Glacial Lake, and here you can see in 2022 how this particular area has changed. So, this is the earlier boundary, right, and this is the 2022. So, how it has increased from this to this yellow color is 2022. So, this kind of analysis can be performed when you are having the satellite image. Now, let us briefly understand what we mean by remote sensing. So, remote sensing is the art and science of making measurements about an object or the environment without being in physical contact with it. To understand the concept of remote sensing, let us take the example of our eyes. So, what happens when there is an object, light falls on it and then it gets reflected, right. So, depending upon the composition, this light will be absorbed and some of them will be reflected. That is basically captured by our eyes, and then we visualize, and then the color of this particular object appears in green in case of vegetation. So, I will show you one typical spectra of vegetation. So, this is the green color. So, green wavelength, right, and this is the NIR. Now, what happens, since our eyes are having the limited vision, we can see up to 700 nanometer. So, this is 400 and this is 700 nanometer. So, you can see our eyes are sensitive up to this 700 nanometer, and here the vegetation is having the peak reflectance at this green wavelength. So, green is the wavelength which is not absorbed by the target. So, in this case our eyes sense this energy and this particular target appears as green, right. But if we would have seen this particular wavelength region, we would have seen them into different color. But since our eyes having limited vision, so we are able to see the vegetation in green color. So, the example of eyes are only to understand this concept of remote sensing. But whenever we talk about remote sensing, it is essentially a instrument based measurement. So, here you can see a satellite which is carrying the payload. Payload is basically your instrument or sensor through which we are able to generate the images of this particular area, right. I will repeat this concept. So, we are able to see an object when light reflects from it, falls on our retina for our eyes, and the brain recognizes the object. This is how it has been looked. The sensitivity of our eyes is limited to the visible region of the electromagnetic spectrum, that is 400 to 700 nanometer. As you view the screen of your computer monitor, you are actively engaged in remote sensing. Now also you are doing the remote sensing, but the accepted meaning of the remote sensing refers to instrument based technique. So, here you see this particular instrument which is continuously generating the images of earth, right. In remote sensing, we use the electromagnetic wavelength ranges. Now, different wavelength ranges have different properties, and based on that different properties of the target can be identified or it can be measured. So, when we are talking about this 400 to 700 nanometer and 700 to 2500 nanometer, we call it reflective domain. That means the energy which is getting reflected from the surface itself is getting captured in this particular wavelength range, and it is called reflective domain or reflection we are capturing. In further longer wavelength region, here you can see that thermal infrared 2.5 micrometer to 16 micrometer. So, what happens when an object receives the energy? There are different phenomena, right. So, some of the energies will be absorbed, some will be reflected, some will be transmitted, right. So, if the material is absorbing some energy, it will release at the longer wavelength to maintain the equilibrium with the surrounding. So, this temperature will be released, and this can be measured in 2.5 micrometer to 16 micrometer wavelength range. So, we call it emissive domain, right. Now, the next wavelength range, that is from 0.1 centimeter to 1 meter. Here we measure the back scattering value, right. So, this back scattering value will provide you the information about the surface and subsurface, right. And here the wavelength is long, because if you compare the wavelength of visible range, then VNIR, SWIR and the thermal infrared. So, slowly we are moving towards the longer wavelength range, and this longer wavelength range will have less energy, right. So, we will discuss all these pros and cons of different wavelength range in subsequent lectures. I wanted to make sure that you understand the difference between space-borne satellites, the payloads and the sensor detectors. So that's why, so this particular slide will explain the difference between the satellite, payloads, sensor, detectors, how we are performing the remote sensing from space. So when we talk about the space-borne satellites, so they are the carriers of the payload, right. So remember, satellites are the carrier, such as instrument, equipment or system designed to perform specific functions or tasks while in orbit, such as communication, observation or navigation, that is done by these payloads, right. So payloads, this is one example. The scientific or technological instrument carried on board a satellite for a specific purpose is termed as payload, right. So these payloads are mounted on this particular satellite. So satellite sensors, now we are talking about the payloads. The satellite sensors are instruments mounted on satellite orbiting Earth or other planet, capturing data across various electromagnetic spectral band about the surface and atmosphere, including images, temperature and other parameters, right. So here you can see these satellites are basically looking at this particular planet and they are sensitive in a specific electromagnetic wavelength, right, and using that energy they are generating the images and subsequently those images will be analyzed and different parameters will be retrieved for our analysis. So when we say satellite, it is having a field of view. You can see here, it is looking at the ground. So this is a carrier. Now when you have the payload, this is the payload. Now these payloads are basically bundle of detectors arranged in such a way that they are sensitive to a particular wavelength and they are capable of generating different images captured in different wavelength at the same time. So when you see the enlarged view, so these are the detectors here and these detectors are looking at the ground with certain field of view, right, and they are generating the information about the target or the area. These measurements are arranged in a manner so that they appear as this image, right. So basically what we are doing, we are measuring the reflected, emitted or backscattered energy using a sensor, and this sensor is sensitive to a particular wavelength, and using that particular wavelength information this image is generated. So if we zoom it, we will find these are made up of small check boxes, right. So those are basically your pixels, and for each pixel you have digital number, which is the reflected, emitted or backscattered energy. So if you just try to import this in any programming language, those pixel values will be seen. So this will be like this. So now in remote sensing, we are more bothered about these values, how precisely or accurately we have captured this information, which is representing the properties of the target, right. Here you can see how we can perform the remote sensing from space. So you see this video, it will help you to understand how satellite sensors are sensitive in a particular wavelength, are looking at these grounds, and then these images are generated the way we are seeing the object. Only difference is this is instrument based measurement, right, and here we do not store this, This is just to understand the concept. Right. Now you might be wondering that how remote sensing images are different from our regular camera or from the mobile phone images. Both are same, because you are not touching the object, you are generating the images using the electromagnetic wavelength ranges and a sensor, right. So in your normal or regular mobile phone or your camera, you are generating only one image at a time, right. But in remote sensing or the satellite based measurement, we are generating multiples of images at the same time using different wavelength ranges, right. So that you will be able to understand here. So all these images are generated using different wavelengths, right. So these wavelengths are used. So if you compare this pixel of all these images captured by the same sensor, right. So they are looking at the same target. So target remains same, only the wavelength is changing. So you can extract these values and you can plot them here. So this is wavelength versus DN value or reflectance or emittance or the back scattered energy. If you plot, you will get this kind of spectra, right. So this spectra will be able to tell you that these are the wavelength ranges where things are happening. I will explain this concept in subsequent lecture of this course, right. When we capture our images with mobile phone or DSLR or any regular camera, we have only single band image. But when we talk about remote sensing products, we have same time measurement of different wavelength. We have captured different wavelength information in different images by the same sensor at the same time, right. So that advantage we have, and the different wavelengths will tell you about the different characteristic of the target or the area, right. So those things you can extract or you can use to extract the information about the target when you are working with remote sensing images, right. So here this particular slide will tell you how you can visualize the images, because when we talk about our mobile phone images, they are only RGB, 3 bands images combined together so that we can see the images in true color. So green appears as green, red appears as red, blue appears as blue. But in remote sensing images, this flexibility you will have. So you will also learn in this course how you can display your data in different color composite, right. So when we talk about a display system, it has 3 color guns, which is the primary colors, and here you have the option, you can map it with any wavelength range data, right, and then you can display your image here. So this particular course will introduce you to the state of the art concepts and practices, and avalanche, flood, drought, landslide, cryospheric hazards that will be covered in this course. And initially I will be covering this remote sensing and GIS in brief, so that you will be able to follow my lectures when I will be talking about these natural hazards. There are few suggested readings for this course. So this is listed here, so you can take a note of this, and if you are interested you can go through them. You will learn more concept which I will not be able to cover for remote sensing, and I hope you will enjoy this course. Thank you very much.